Welcome, everyone. Welcome to the Careers in Analytics by Ellie Lynch. I have a brief statement to read to you, seeing that this session is being recorded. So it's our audio and video recording notice that has been presented to us through our Marketing and Communication Office. This virtual event may be recorded on behalf of Illinois Institute of Technology. The recording, including participation by audience members, such as by asking questions, may be shared on the internet and or used for promotional purposes. By joining this online event, you acknowledge that you have been informed that you may be recorded as part of the event for any and all media now known or hereafter devised. Further, by your presence, you grant your permission for your likeness and voice to be included therein without compensation, credit, or other consideration. If you want to avoid being recorded while watching this virtual event, please keep your camera off and microphone muted, and do not engage any video conference features that will be visible or audible in any way to other audience members. Thank you for your cooperation. My name is Helena Zenwa, and I am the Assistant Dean for Stewart School of Business at Illinois Institute of Technology. I'd like to welcome all of you to our session this evening and morning for some that are not close to us, but thank you very much for joining. I would also like to just go over a few housekeeping items. If you are not speaking, please, if you can keep your audio on mute. If obviously you heard the statement, so if you're uncomfortable, you're fine with keeping your camera off as well. That's up to you. But yes, just if you could do that, we will take questions. You feel free to use the chat function to enter your questions throughout the presentation. The presenter will speak, and then at the end of the presentation, we will have time to take on questions as well. So please use that chat function to make sure you can kind of keep track of the things that you would like to ask. That being said, I'm going to turn it over to our Senior Associate Director, Mr. Shahzad Hussain, to introduce our speaker. Shahzad?
Thank you, Ellen. Ellie, thank you for taking out your precious time to speak to our students today. It is my privilege to introduce you. Ellie Lynch is the Director of Data Solutions at EN Engineering LLC. She is a data analyst and artificial intelligence professional with proficiency in resolving complex issues while leading and developing high-performance teams. She has strong leadership and data science skills with advanced analytics abilities. She has a bachelor's degree from Illinois Institute of Technology in Civil Engineering and a master's degree from Northwestern University in data science with specialization in artificial intelligence. I now invite Ellie for her presentation.
Thank you very much. I'm going to share my screen, and if you can let me know when it comes up, I'd appreciate it.
Now we see it.
Excellent. Well, thank you very much for inviting me to be here. I'm excited to talk to this group. As you just heard, I'm the Director of Data Solutions at EN Engineering, and you've heard a little bit of my background, so I'm going to jump over that and dive right in. Today, I'm going to talk a little bit about how EN Engineering uses data analytics to support the energy and utility sectors with a fairly diverse team of individuals and what that looks like within our industry. And so a little bit of background on EN. We're an energy consulting firm across the United States. We're approximately 1,800 people, and 92 of those folks are on the data solutions group and in 7 different locations. Our team members are engineers, programmers, database developers. We've got some environmental scientists, a couple of business folks. Large variety of background is part of what contributes to the functions and ability of our team to meet our clients' needs. So a little bit on what our team does. So within the energy and utility and oil space, data is used to optimize various systems. It's used to not only a financial analysis to make sure that the companies are optimizing their finances, but also on the asset management and energy management systems so that these companies can leverage data to make better decisions. So our consulting group, which is focusing on data solutions, provides full spectrum data services from the capture of information, so digitizing documentation, collecting data in the field, identifying mechanisms for bringing in information from the genesis of that data component all the way through to leveraging it and using it to analyze their system. And this is a fairly broad spectrum of services that's provided that does require that diverse background I spoke to in the previous slide, because it's not just taking information in a spreadsheet and generating results, but looking at the entire data system that our clients or the energy industry is using and designing the system so that they can leverage each component for a variety of purposes and for the long term. So you'll see here we've got, the capture, integrate, and analyze, but across all three of those services that are provided, the data system design and development is absolutely critical in kind of building these processes and infrastructure for the long term for that organization. So in a couple of things to note, we will do work in a variety of ways, whether that's inside the client system, where we're coding or programming or pulling in information from various databases or data structures, or doing it on our side and saying, okay, yep, we got that export, we're going to analyze it and provide a result. And so over the past number of years, the platforms that are used for data analysis and applications within the energy space have been evolving, where previously a lot of it was done within the confines of a static deliverable, and more softwares are coming out as a software as a service, where the organization is interfacing with a external third party. So you go out from your utility organization to the vendor or analysis platform, and then you bring the results back into your data model, which is this software as a service. Or there's on-premise softwares that are used custom, or these kind of in-system development where you're coding them one-on-one. So with that being said, we'll talk about some of the individual applications of the data systems and analytics throughout it. One thing to note, there's a large focus on spatial data and leveraging spatial data to drive insights. And so our organization, the Data Solutions Group, grew up out of a GIS team where we took spatial data and then expanded it to fit into the greater infrastructure, the greater ecosystem of these utility clients. And so some of the softwares that are used are GE Electric Office or Esri Utility Network, which are kind of cutting edge solutions that will allow these utility companies and energy companies to manage their assets in a more efficient and effective manner, and pull those variety of data sources into one place so that they can be analyzed against their other information within that location. So keep that in mind as we go through, because many of the solutions we'll be talking about are going to be spatially relevant and not just data relevant. It's kind of bringing the science of where to data analysis. As mentioned earlier, one of the most important pieces of a data system is making sure that your workflows and your processes align to the overall business needs of that organization. And being able to complete one analysis is great, but if you're not establishing processes to get data into the system and be maintained as quality, it won't be a sustainable package or sustainable solution. So a large part of what my team and the organization does is focused on process development. When we do process development work, this involves sitting down with stakeholders and saying, what's the problem that you're trying to solve? And then they answer with the problem that they see, and you go to somebody else and you ask them, what's the problem you're trying to solve? And all of these people who are stakeholders in their analysis, whether you're trying to build a program to evaluate how risky a gas asset is and predict the failure of a specific asset, everybody has a different kind of stake in the problem that you're working towards, and that problem isn't necessarily the same across the board. And so one of the first things that we do in these types of projects is sit down with all of the different stakeholders, identify individuals' problems and where their pain points are, and then evaluate where the origin of or the actual issue is that this initiative is trying to solve. And a large part of where we see the issues come down to are these workflows. And so you can kind of see here we've put workflow development on here, and it's one of the most important aspects of any of our analyses or processes. And it's very hard to do an analysis or an analytics solution, whether it's a one-time analysis, without hitting on, is your workflow sustaining your data? Do you have a mechanism for getting the right information in? And once you get that right information in, how are you as an organization, or how are you as a team maintaining it so that it's consistent and that you can trust the results, not just this one time we're analyzing it, but every other time you run this analysis? Or if it's an ongoing analytical deliverable, what is that? Will you trust it every time you look at the results? So can't emphasize more the critical aspect of being aware of the problem that you're trying to solve and making sure that you're solving the issue, not just the one that's right in front of you as a part of the project, but kind of overall within the bigger ecosystem. And one thing to emphasize, this is only going to be more and more important as our industry or any industry evolves. You know, I'm assuming everybody here has worked with databases at some point, but every single organization continues to add more databases to their system. And every time they add a database, or every time you add a program or some sort of management system into a company's ecosystem, that workflow development is essential for making sure you don't have duplication of information in one system, and then you can edit it in both, and then you don't have you've conflicting records, or you don't have consistent records throughout your entire organization, and then or different aspects of the organization can make different decisions. So just understanding the process, understanding the bigger picture of the data system is one of the key foundations before we even start doing the analysis, because that's where you can make sure it's a successful initiative or project or whatever you're working on. So speaking of kind of that process, if we think about the steps to go into the analysis or into the analytics or applications of analytics, we take a step back and say, okay, how is this data being captured? The capture of information is where you get, if you're capturing it right, that's where you can guarantee that it's going to go into your system correctly. And so, as I mentioned before, the first piece here is that process development, identifying and optimizing the data input workflows. It's incredibly expensive to get good data in, but once you get it in, it can pay for itself many, many times. And then also doing the data input is another piece. So designing the programs to make sure that you're going to get the information that you are then able to analyze. If you don't have good data, you can't get good results. You can't get good outcomes. So this is one of the primary focuses of many of our projects, is just getting that capture set up so that you have information feeding your marketing, your markets group, your operations, everybody who's working within this organization captures the data as necessary. A nuance to data capture is often that you're capturing different components in different places, and it goes back to this design and development, because many people are going to be, hitting the interfacing with the information in one place or interfacing in another place, and it's making sure that they all come together into one concise location so that it can then be used to actually drive those insights. One of the mechanisms that's used is field data collection. This is, it sounds like it's fairly simple. This is a little bit different than the surveying that, if people have civil engineering backgrounds, people are probably familiar with. But when it comes to field data collection, there's been many advances in the field where you're able to get centimeter grade accuracy on some of these GPS devices. So going with device agnostic smart forms, getting the information to the point of creation. So when a pipe is installed, when an electric meter is put out there, pushing towards Internet of Things, how are you going to, tag the different location of that smart meter back to the greater network that we're analyzing that data from? this is where it originates. And that live data capture process that we're kind of seeing the industry move towards allows you to have those standardized real-time data access repositories. Different organizations will pull the data down for different purposes. This is an example of an application that we developed for engineers to get field data, analyze it in a web application, and then getting it into CAD so they can do some engineering and design. So a variety of different applications, but the key thing about this solution here is the kind of overall workflow where you're getting it from the field immediately, push it through, get it into the office, and then do something with it, whether that's an analysis or a design, which is, I guess, a type of analysis. Another large portion of what my team works on is this data cleanup. There's a number of, there's a lot of applications that we can do and analyses we can do. But if you look at this, and this is an example of a project we completed a few years ago, we worked with about 2,500 miles of transmission main where they're transporting gas at 2,000, 3,000 pounds of force or pressure. And if you looked at this, when we started the project, their mains were not anywhere near where they actually belonged in the station. And that's an issue, because when you go to, if you're going to analyze a risk, or you're going to go do predictive failure based off of elevation conditions or something like that, location matters of where that is. You can't dispatch people out appropriately. And so there's a large process where companies who have grown up capturing information in disconnected data systems, or maybe not with a high level of accuracy, are now coming back and saying, we want to do this predictive failure, but to get there, we've got to do a whole bunch of data cleanup. So as a part of the data cleanup process, oftentimes it involves an inventory of the current data and processes. Again, going right back to the workflows, it's one of the most important pieces of what we do is establishing ongoing process improvement and processes that contribute to that good data. But with what's already created, you review what they do, you identify any of the gaps in the systems, and then you get to go into the analysis. And so during the data cleanup phase, a lot of what we'll do is a statistical evaluation of discrepancies within the system, understanding how many data components are missing, or what's incomplete or doesn't match known rules within a utility network or a company's kind of historic design standards. It could be any number of things. Once you've identified or done an analytical evaluation of discrepancies or missing information, we turn it into a triage phase. Some information is more valuable than others. And some information, depending on what the application is, which we'll speak to a few applications in a little bit, is absolutely critical. If you don't have certain pieces of information, it may result in thousands to maybe millions of dollars of fines, depending on if there's an incident or an audit from the federal government. Many of the utilities are regulated by the federal government, especially if you're in the gas industry. You have to comply with data standards and data management and information management processes, and failure of an audit could result in severe consequences. And so during the data triaging or prioritization phase, you evaluate the risk of that data component, and then prioritize how to resolve and address and fix it within whatever parameter is required, whether that's to respond to an audit or to comply, prepare it for a rollout of an advanced data management system. These are all different things that we'll use for prioritization processes. And then there's also one step in here that occasionally can be done, is automating the cleanup process to a certain extent. An example of that would be, we have a couple of programmers who will build logical mechanisms, or sometimes applying artificial intelligence or machine learning algorithms to data sets to identify where there's discrepancies, and then to move or update those discrepancies depending on some of those conditions. So for example, if you look here, this would be composed, this station would have valves and a number of other assets that are mapped within it. And there's certain rules that you can prescribe and say, you know what, a valve has to be connected to either this component, this component, this component, this component. If you have this, it can't be that. And so you can do prescriptive movements or prescriptive changes, or you could do trend analysis where you take the data set or data repository of the entire infrastructure or the entire asset system and identify where there's a higher likelihood of a relationship between a certain component to another component, and then move those items or update those items accordingly. At some point, though, there's always, at least where we are now, there's always a need for a manual review. So if we do an automated data update or conflation process, we give each change a score based off of the likelihood of it matching that change. And then if it doesn't match a certain score, then we'll go in and have individuals manually review who have the domain expertise to come in and make sure that it's been updated appropriately to accept or reject that change. And then back to kind of the most important piece that allows us to get into that analysis component is the maintenance. And so once you do the data cleanup, it's going back to the beginning and saying, all right, you're in a good place now. We've got this station. When you come and do construction, how are we going to get that data from the field into your system? How are you going to make sure that the reporting processes are appropriate? And so these are all so far some of the building blocks of how analytical systems are able to be developed and what the foundation of advanced analytics processes are built on. I think some industries are more advanced than others in this regard. You'll see the financial industry is employing many advanced analytical tools, while the utility and energy industry, some companies are more advanced, but there's still a long way to go for trying to understand how to get these companies to the same place that the financial industries are at. And so then, kind of speaking to the same thing we were talking about earlier, you've built the foundation, you've got the clean data. Now, how can we use this? What do we use this for? So I'll speak to a couple of different case studies, and then I'll pause for questions or I'll speak to high-level topics here before I pause for questions and dive in. This is the most fun part from a personal standpoint. The advanced analysis using statistical analysis, machine learning, spatial classifications to understand not just where things are happening, but what's happening, and then kind of evolving along the analytical value curve from reports all the way up to prescriptive or prescriptive statistics. So many of these, I'm going to step back. When we're looking at employing data-driven insights, one of the biggest things I think that's important for our approach to projects and how our team works on this is that you always want to start with the you always want to start with the problem. The first thing is saying, okay, same way when we talk about building a data system, when we're establishing those processes, what is the problem we're trying to solve? And oftentimes the problem that people think they have isn't necessarily the problem that needs to be addressed. And so oftentimes people will come into a situation with a bias about how they want to solve that problem. And one example is there's a lot of hype around AI and artificial intelligence, and sometimes machine learning algorithms are absolutely the most effective way to go about doing it, but other times it may be the long route to the right answer. And so we try to go in and identify what the problem is first, and then open up the toolbox of analyses or analytical tools, whether it's an Excel spreadsheet, a SQL program, combining some statistics and either Power BI or Tableau dashboards to help expose what's going on inside of there, and make sure we're selecting the correct mechanism to solve that problem. And this is where, for these types of teams, we're working with a domain expert. You've got somebody who knows why you're trying to get to the end result of that problem. You've got somebody who's, a individual who understands the statistical analysis and can make it meaningful to the business folks who may not know what a p-value is, but know that they need to understand what's happening within their system. And then you'll have the programmer or the developer who can make that solution either repeatable or expose that solution to the stakeholders in a format that they want to see or need to interact with. And so some applications that are kind of highlighted on here are understanding the proximity of something. This is a analysis that we did for evaluating if you have a remote valve and you need to shut that off because there's a leak in the system. What is the travel time for somebody to go and turn the valve manually, or do they need to put a robotic valve or an automated valve in place so that they can identify a asset failure and have their system notice a drop in pressure or notice whatever that leak is causing it, and turn that valve so that you have the response time as necessary. And so this is one of the maps showing response times and where there are proposed valves. If you have an automated valve, how many other valves do you need to put in place? So that's always an interesting one because it involves taking in traffic data, understanding peak traffic data, evaluating routes from where the individuals who are expected to operate those valves are going, and then doing the cost benefit between a remote control valve and a fully manual valve, and then seeing, from a response time as a company, do you have a 1 hour response time, or do you have a half-hour response time you have to hit, and what's the environmental impact that may happen because of this design change. And so this is just an example, and we'll go into some more, but I'd like to just pause for questions before I dive into case studies.
We have one question. Does the team use statistical tools like R as well to develop the custom algorithms, since you mentioned the use of statistics?
Absolutely, and great question. We use a combination of different tools for statistical analysis. This chart was generated using Python. And as an organization, we've made the decision that we're a Python shop. So a few people dabble in R. I know some R, a number of individuals on our team are familiar with it. However, most of our analytical programming is in Python, largely because of our affiliation with geospatial or GIS software, which is more compatible with Python than with R. Another tool that we, or mechanism we use for exposing statistics to people who may not be well versed in the statistical background and wouldn't want to kind of get their hands into R or Python or something like that is using dashboards, which can present statistics in a meaningful manner to people and allow them to drill into the original data without having to kind of do the programming themselves or click through a spreadsheet. And so some of the tools that we found to be really beneficial for our team is either familiarity with Python or a deep knowledge of Python, the ability to build dashboards through Power BI or Tableau or a solution like that. And then I think more importantly than either of those, one of the biggest skill sets or most important skill sets is being able to speak to what the statistics mean. Throwing a histogram up doesn't tell people who aren't familiar with that sort of analytical process what you may want it to tell them. So you have to be able to clearly express the meaning behind it in a way that's not too academic, but helps them understand why it impacts their business decision. Any other questions?
Do you use Tableau or Looker software?
We use a Power BI. We've used some Tableau. It does depend on what. If we're hosting it internal to our company, we'll use Power BI because that's just how our platform is set up. However, other organizations may have chosen to adopt Tableau instead of Power BI, and so we'll operate within that platform, and we have people who are familiar in both.
Any other questions? Okay.
Excellent. For the next part, feel free to just ask questions as I talk through them. They're going to be specific applications or case studies of some of the solutions that we've provided and examples of ways we've addressed some of the analytical needs within the industry. So, as I mentioned, EN is a engineering firm or is an energy consulting firm that has its roots in engineering. And so some of our first solutions were around facilitating the design or helping the engineers make the right decision for the long term. And so on the left, you're going to see that clip and ship. That's the one I referenced when we were talking about mobile data. This is a geospatial tool where folks out in the field collect information. It feeds up to that database. This web map is updated in real time, and you can select a particular region and pull that down for the design. It's an efficiency, it's brought efficiency to the teams, and it's also enabled those engineers, once they do the design, they load it back up so we can understand, you know, how much of the area is changing with each design. For this particular project we've probably mapped over 60% of the city that we're working in there. So it's a fairly large data repository that's allowing us to do more and supporting the design of our the efficient design of the engineering teams. Over on the right is one of my favorite types of analyses or examples of analyses for pipeline or route assessment. So what you're seeing on the map is the result of a combination of a variety of data sets that were then scored according to the cost of construction and then generating the most optimized route. And so what I mean by that is we took a large number of data sources, from parcels to roadways to rivers, rails, the pavement. So, and we'll look at pavement analysis in a little bit, but pavement versus permeable areas. And we assigned a cost or a value to each cell within that data set, and then ran an analysis to evaluate what was the most efficient method for going from point A to point B. And then identified a number of alternative routes. And then as we honed in on where we wanted to go, ran additional other side routes to say, yep, it's cheaper to go around this house because that lot is going to be this amount, or you know, going under rivers for pipelines or large waterways, you have to dig very deep to go under it. It's going to be a shorter path to go here, or we can attach it to a bridge here. So this is the outcome of a spatial analysis requiring multiple layers of information, and also another component is population information that contributes to it, because you don't want high pressure pipelines near people. So proximity to high population areas or sensitive areas is another weight within this analysis factor. So now the next piece is going into data-driven designs with raster processing. And for folks who aren't familiar, rasters are essentially pictures or data sets that are set up to have values in grids. And the best example of that is a picture. So in a picture, when you're thinking about your typical kind of RGB values, every single cell has a unique RGB value that contributes to the overall picture, giving it its particular shading or coloring. And then the combination of all of those pixels is what creates this picture. Well, if you think about a black and white photo or a color photo, actually starting with black and white, you've got, you know, zeros and ones of, is this pixel black, is this pixel white? And then if you go to a color photo, you've got multiple bands of data, red, green, blue, where that value in one location stacks up. And so what you're seeing here is a clustering algorithm that we run on imagery to identify where there is pavement, so non-permeable surfaces, and where there's permeable surfaces, and where there is water, where there are water bodies. This segmentation can be used to also distinguish where there are building polygons, and evaluating or identifying different types of objects within images, which I'm sure everybody here, or I hope folks here have run across image processing within machine learning or AI processes. When you're doing image recognition with your phone and it identifies a face, it's doing that same sort of analysis where it can identify shapes by evaluating the patterns within those layers of or bands of data. And so the same way that's being done, we're identifying the locations where there's permeable pavement. And this has a large variety of applications. One of them is identifying building polygons. So that is useful within the utility space, because knowing where your customers are and knowing where the population is helps, could be applied to identifying where a utility wants to expand a service territory, or it could be used to evaluate the risk or the threat that a specific asset may have within a certain location and plan work according to those risk scores. So this is one example of raster processing, and you can kind of see the before classification, the after classification. I'm sure the resolution of the input data is essential. If you don't have high resolution information, the boundaries between permeable and non-permeable are going to be less clear. And so there are limitations to applying some of those analyses. So I'm gonna pause there again. Any questions so far?
There is one question. In construction, cost and time plays a major role. Which softwares or ERP are popular in use in planning, scheduling, controlling of construction projects?
I can only speak for the utility space. So keeping in mind that is going to change outside of this industry. The ones that we've seen or interact most frequently are SAP is common within utilities. So is Maximo. I'm not sure if anybody here is familiar with it, but it's a program designed by IBM, I believe, for the utilities and energy industry. So I'd be surprised if it was common outside of it, but that may not be the case. I'm not familiar with it outside of the industry. And then there's a combination of other programs that may be deployed, which could include Asset Suite, which is also, again, which is another asset management program that would be integrated or potentially integrated into the cost or construction management. Did that answer your question?
I think so. There's another follow-up question. Do you use planning tools like Primavera or Microsoft Project for planning scheduling?
We sometimes. There are a couple of different project models that may be used, or product deployment models, depending on what we are building. In some cases, there's a clear waterfall schedule that we're following, where you have task A, task B is dependent on task A, you've got C, task D is dependent on task B, and you know from the get-go that it's a project duration of 3 months or 8 months or whatever that may be, and here are the tasks we need to complete in order to have this be successful. And that is most frequently tied to the physical asset construction. So if we go back to the route assessment, this route assessment is a construction project. And so when we were working with it, we were tying into a waterfall plan overall, where our piece was just a small part of that bigger Gantt chart that establishes kind of the workflow and who's doing what and when. On the other side of it, when we're doing our either analytical program development or some of these more advanced analysis modules, oftentimes having a waterfall or Gantt chart in that mechanism isn't effective, because the success requirements or functional requirements of that solution may evolve as insights into the data or insights into the value of what you're working on are exposed through the various subsets within the project. And so we may run a project as an agile project, or sometimes we call it agile light, just depending on the requirements and who or what organizations we're interfacing and how they're expecting the deliverables to be run. But typically, for some of the more complex analyses and ones that have many data sources coming into them, we will run it with an agile approach, whether it's true agile with a Scrum, and that depends on the project, but it will use different tools at that point in time.
One last question: how asset management is managed in various, how is, I guess, asset management managed in various projects?
So asset management is one of the biggest needs right now for, or one of the biggest applications for analytics within, I'd say, the utility space. And I may not be answering your question directly, but I'll speak a little bit to some of the applications of asset management systems and what's going on within our industry right now. The first one is, speaking with the electric industry, there's ongoing and widespread initiatives for organizations to improve their assets and to optimize their assets and the management of their assets very effectively. And so that means organizations are attempting to do predictive failure analyses, where they want to find the transformers that are going to fail and replace them right before failure, or just-in-time replacement. Whereas historically, if you don't have enough information to understand when something's going to fail, you're trying to replace it before it fails, so there's no downtime. And so that often, you know, depending on the component, you may schedule it so that it's going to be replaced, has a typical life cycle of 22 years. Well, we're going to replace it at 20 years, or we're going to replace it at 21 years. Or depending on the component, if it's more cost effective to run it to failure and then replace it, that's another mechanism. But then you have to kind of balance the costs of the downtime and then the replacement, and what are the other implications to the system. And so one of the big drivers right now, especially with the implementation of asset management solutions or suites, is to build a data repository that houses all of the, has construction, the attribution of that component, all of the maintenance activities that have gone on, any of the failure information, identifying failures as early as possible so that those failures can then be used as a feedback loop into the evaluation of or the analysis, saying, when is this other component that has a similar profile to it going to fail? And so asset management as a whole is pushing towards the predictive failure analysis and ultimately looking to turn that into prescriptive, a prescriptive application of analytics, where instead of saying, okay, we're going to predict that it's going to go wrong, you say, if I do this, what's my optimal approach to mitigate that failure, so that you're prescribing what your solution is after you've predicted it, if that made sense and answered the question.
I think it did.
Excellent. Any other questions before I go on? All right. So, oops. So the other piece here is kind of the 3D data. Through many of the advancements in sensors and LiDAR scanners, we're able to interface and interact with more complex data sets. And what you see here is the result of one of our analyses, where we classified LiDAR data, identified what the ground, through that same a similar application of image recognition, except it's with 3D versus just 2D pictures. The information, we were able to classify and get the ground removed, and then identify what is vegetation, what is a rooftop, and then this is showing what it would look like if you were to map out and identify where your power lines were. assessing where there's vegetation conflict with those power lines. And this is another key piece of power line asset management as well, to tie it back to the previous question, where you'll have power poles, and if your tree grows and it comes in and cuts and impacts your power line, you could cause an outage for a neighborhood, you could cause an outage for the entire subsystem, depending on what that outage is or what that line is feeding. And so vegetation management is a huge portion of electric utilities managing their assets and making sure that they're clear. So flying right-of-ways with LiDAR scanners, evaluating where there's a proximity. So if you look, anything in red here is where it's within 5 feet, anything in orange is within 15 feet. That's an example of 3D analyses. And then the last example that I'd prepared for today is using data for system risk modeling. And I've spoken a little bit throughout this presentation on or mentioned risk. And when we're talking about assets and we're talking about either gas or electric assets, the risk of failure or the risk of something occurring is an important metric that is used to identify when there needs to be a replacement, to plan out the next 10 years of construction projects, the next 10 years of either replacement and or maintenance programs. And it's used to help companies understand how they need to manage their workforce and their operations so that they're maintaining a reliable and resilient system, not only so that there aren't power outages or you don't run out of gas, but also so that the assets themselves maintain a safe operation. And so when we're looking at system risk modeling, we will take layers and layers of spatial information from drainage pathways, water flow, population information, proximity to roads, the number of people in an area, what the wall thickness is, what the asset life cycle is, anything that might be a factor within that could contribute or help us understand if there's a potential for that component to fail, and then run a complex analysis that takes the likelihood of failure times the consequence of failure, and then ranks those assets according to the outcome of that risk. And that is often applied across the entire system. And some of the analyses that we work with may take in anywhere from 50 data sets up to 98, 100 of unique data sets that are all tied into this spatial system, and then analyzed and evaluated to help drive the 10 and 15-year plans for the organizations. So those are all of the examples that I prepared for this presentation. Are there any, I was saving 10 minutes for questions or conversations, or if we want to talk about something that we didn't cover in here, happy to answer any questions there.
How advanced analytics are utilized for optimum use of inventory management?
So I'm not, we haven't worked on those types of projects, and I'm not familiar with that necessarily in this industry. So if we're talking construction inventory management, oftentimes there are components that are used regularly. 2-inch couplings are installed all of the time, and a company will just have enough on hand so that they can go out with the trucks, or they may even be in the truck. It's considered truck stock. And then for the more complex components for construction, like maybe it's a 20-inch valve or something like that, there's a lead time in ordering it. So if you know you're going to work on replacing something that has those larger components, you want to plan ahead. It's hard on some of the really big ones to get them in time or make sure they're not delayed. If we're talking, yeah, I don't think there's a great example from like a distribution center or something, an Amazon, where this would be applied, because we're using a different sort of inventory here.
Okay, here we have one more question. Apart from a degree in analytics, what other skills are valued in your company for entry-level employees?
So I think, and this goes back to one of the comments about statistical programming languages. I think one of the most important skills is clear communication, and being able to convey complex technical topics to folks who have a different background. So oftentimes when we're interfacing with people who are not of a statistical background, talking to some of the Bayesian statistics or those things just kind of misses from the audience level. And so I think one of the most important skill sets is being able to understand your audience, know their technical considerations. They often have a domain expertise that's outside of the realm of whomever's running the analysis, and so they can provide a detailed insight of why that analysis matters or what's flawed with the statistical outcome, but also being able to convey it in a meaningful way to somebody who doesn't have the same background. I think that's number one. And then the other one is the ability to take a step back and understand context of what you're trying to solve. Coming into a project, folks who come in and can follow step-by-step directions, that's important, but more importantly is looking at those steps of do this, this, and this, and understanding or being able to ask the question of why am I doing that? Because by understanding why you're following a step-by-step process enables whomever's doing that step-by-step process to either identify flaws, identify a undesirable outcome of something that's going on, and also to take the same understanding and apply it to the next project that may not have a step-by-step process already defined.
We have one more. Are there any internship opportunities available in the analytics space which would probably lead to full-time employment?
There are not internship opportunities right now. There are some openings for the data entry and data cleansing group. So if you want to send me your contact information, I can connect whomever's interested with our HR group, and they'll work through the processing.
So students can feel free to reach out to Shahzad and Helen, and we will forward any contact information to the speaker. Are there any other questions? Okay, I'm transitioning over to you, Shahzad.
Thank you, Ellen. Great. I'd like to take this opportunity once again to thank Ellie Lynch. I think, Ellie, this has been a great presentation for our students. Thank you once again for taking out your precious time to be with us and talk to our students today. Also, thank all the students who have participated in this presentation. I am pretty sure that you have benefited from Ellie's knowledge and experience. Thank you all for making it to this presentation, and we look forward to keeping in touch with you for more presentations that are coming up ahead. Once again, thank you, Ellie.
Thank you. Thank you for having me.
All right, then we will call it a day. Thank you all very much.